This is Miss Sebastian, and we're going to look at Unit 4, Probability, and this is the Unit Test Part 2. So we're going to look at how you can go through a similar problem than the one that you are looking at. So this is kind of what your problem looks like. I changed the wording a little bit so that my problem is a little different than yours, but you get the idea of how to solve. So the diagram below shows the contents of a jar from which you select marbles at random. What is the probability of selecting a green marble, replacing it, and then selecting a red marble? Make sure you show your work. So the first thing we need to do is count how many total marbles there are. So I'm going to count in the jar. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 total marbles in the jar. And I need to know how many green there are. So there are 1, 2, 3, 4, 5. 5 green. Then I'm going to put the marble back in, and I'm going to get a red one out. So there's 1, 2, 3, 4 chances of getting a red marble out of those 16 because I put them back in. Okay, so now because it is 2 independent events, I'm going to multiply those together to find out the probability of getting those 2 events in order. So I'm going to multiply across the top. 5 times 4, that's 20. And 16 times 16, that's 256. I can simplify that down by 4. So 20 divided by 4 and 256 divided by 4. That'd be 5 over 64. So we're done with that one. We're going to go down to Part B. What is the probability of selecting a green marble? Well, we already figured that part out in the first problem. It was 5 over 16. Set it aside so we don't put it back in the jar. And then select a red marble. So we still got 4 red marbles in the jar, but we didn't put that one back. So now there are only 15 marbles in the jar. So we multiply these out, and we get 20, and 16 times 15 gives us 240, and both of these are divisible by 20. To simplify, so I get 1 out of 12. Now these two numbers are different. So what I want you to do is tell me why those are not the same. Now I'm not going to give you the answer. You do know they're different, but you have to tell me why. Tell me what you think. All it has to be is a sentence or two. Hey, I think they're different because this, and write it out. Okay, a box contains 90 pink rubber bands and 95 brown rubber bands. You select a rubber band at random from the box. Find each probability and write the probability as a fraction in simplest form. So the first question says, find the theoretical probability of selecting a pink rubber band. So pink, we know there were 90 pink. I'm just going to put a P there. Out of how many total? Well, there was 90 and 95. So that's a total of 185. Okay, now we need to simplify. They can both be divisible by 5. So we get 18 over 37. Now we're going to find the theoretical probability of selecting a brown rubber band. So there were 95 brown rubber bands over 185 total. Those also we can simplify by 5. So we divide the top and the bottom by 5. So we get 19 and 37. Okay, so then we can go to our third one. You repeatedly choose a rubber band from the box. Record the color and put it back. The results are shown in the table below. Find the experimental probability of each color based on the table. So we had 28 pink and 39 brown. So we need to find the total number of times that they drew. And we're going to do that by adding 28 and 39. So 8 plus 9 is 17. We carry a 1. 2 plus 1 is 3 plus 3 is 6. So 67 is the total. So the probability of getting pink would be 28. That's the number of pink right here, out of the total. The probability of getting brown would be 39. That's the number of brown, out of the total. And that is all you will need on that one.